Hello, everybody. So we've got a new rule now, and it's the power of zero. And basically, anything to the power of zero, according to this rule, equals one. But let's explore that. Let's prove it. If I've got a squared divided by a squared, in other words, I've got two a's up the top here, I've got another two a's down the bottom. I just cancel that out. That divided by itself equals one. Now we know that as an absolute rule. Now let's use our index laws to do the same thing. If I've got a squared divided by a squared, that's the same as saying a to the power of 2 minus 2. So 2 minus 2 equals 0. So by definition, if we've got a to the power of 0, we just proved before that a squared divided by a squared equals 1. So a to the 0, it's the exact same process, but a to the 0, therefore, by definition, has to equal 1. And so, if you didn't get that, you don't really need to. All you need to do is be able to remember this rule. So, glitch there. So let's do some examples. So if I've got a situation where I've got 14p to the power of 0 divided by 2p squared in brackets to the power of 0. What you notice is that with all of our index laws, to do the next one, you need to be able to do the index law past. And so they're cumulative, they add up. And if you miss one, you're going to find it hard to do the next, and then the next, and then the next. So let's have a look at this one. Let's just simplify it out as best as we can. Let's keep that 14p to the power of 0. But what's this? 2p squared brackets to the power of 0. We know that's the same as 2 to the power of 0 and p squared to the power of 0, or p to the 2 times 0. Now we've established before that anything to the power of 0 equals 1. And so 14p to the power of 0 is just another way of saying 14 times 1, because p to the power of 0 equals 1. And 2 to the power of 0 equals 1, because it's to the power of 0, times by p to the 2 times 0, which equals 0, which equals 1. So this question would be 14 times 1 over 1 times 1, which is just 14. So let's have a look at the next one. If we've got minus 6 r to the power of 0, what do we do here? Well, let's put in the times that we always leave out. That's just the same as saying minus 6 times r to the power of 0. And we just established before that r to the power of 0, or anything to the power of 0, equals 1. So that's just the same as saying minus 6 times 1, which equals minus 6. That's quite an easy one. Now I've made a slight change and I've added a question here because I think it needs to be spoken of. If I've got minus 6r in brackets to the power of 0, that's a very, very different proposition to the one above, which is minus 6r to the power of 0. Because what this is saying, or this question here, is that everything in the brackets, the bag that's the brackets, is to the power of 0. So that means that it doesn't really matter what's in here. It's to the power of 0, therefore it has to equal 1. Finally is this question here, and this is probably the hardest one. Because, again, we need to be able to do all of our maths, all of the laws that we did prior, or rules should I say. 3x cubed, or should I say 3x cubed is the same as saying 3 cubed x to the 3 times 3 divided by x to the power of 9, which is 20. 3 cubed is 27. X to the 3 times 3 is x to the power of 9 divided by x to the power of 9. Now, here we've got terms that we can subtract. Because they're dividing, we have to subtract the indices. So we end up with 27 x to the power of 9 minus 9, 27 x to the power of 0. And I'm running out of room here. But 27x to the power of 0 is just saying 27 times x to the power of 0, which equals 1. That's 27 times 1, which equals 27. These are pretty easy, but they can get a bit complicated, so I really seriously recommend that you practice them. So to recap, for the millionth time, anything to the power of 0 equals 1. Please write this down in here. And make it nice and handy so that you can refer to it just in case you forget. Okay.